talked a little bit about how models make weather forecasts, how climate models make weather forecasts. Now let's talk a little bit about how humans make weather forecasts. And actually, by the time we're done with this, you may even feel confident enough to go outside and make a weather forecast. So let's jump in. So, how do humans make weather forecasts? Well, there are four main techniques that human meteorologists use in making forecasts. And these are all pretty simple techniques. The techniques are called persistence, trend, analog, and climatological. A persistence forecast simply states that whatever the weather's like right now, it'll be like that later. The conditions will persist. Things will stay the same. So, for example, if it's 72 degrees outside right now, then a persistence forecast is going to say that it'll be 72 degrees an hour from now, or 72 degrees 2 hours from now. Or if it's 72 today, it's going to be 72 tomorrow. Now, these are pretty easy to make forecasts. They're very basic. In fact, let's have you make a persistence forecast right now. Take a moment, pull out your cell phone. If you're watching this on your cell phone, hit pause, open up your weather app, see what the current conditions are. Now make a persistence forecast for an hour from now. The persistence forecast is the same thing as the current condition. Whatever the current weather is, that's what it'll be an hour from now. So whatever the current temperature is, that's what it'll be an hour from now. Whatever the current dew point is, that's what it'll be an hour from now. And so on. Now, these are really good short-term forecasts. Why? Because weather conditions don't change substantially over a very short period of time. However, the further you get away from that period of time, the less accurate the forecast becomes. For example, let's say it's 3 o'clock and the temperature outside is 85 degrees. Is it going to be 85 degrees at 11 o'clock at night? Probably not. It's probably going to be cooler that evening. As the sun goes down, less radiation, the earth gives off more than it gets, the earth is going to cool down, right? So, in that case, a persistence forecast is really only good for the short term. Now, to make slight improvements on that, rather than assuming that the current conditions are going to persist, we can assume that a current trend is going to persist. And this is what's called a trend forecast. In the case of a trend forecast, you identify a current trend and you assume that that current trend is going to continue to apply. So for example, let's say an hour ago it was 70 degrees. Now it's 72. So between the last hour and now, it warmed up 2 degrees. Applying that trend for an hour from now, it would be 74. Applying that trend for 2 hours from now, it would be 76, and so on. Another good example, the one I put here on the screen, if it was 68 on Saturday, 70 on Sunday, and today is Monday, we would say, okay, well, it's going to be 72 today. So the change between Saturday and Sunday was 2 degrees. So the change between Sunday and today will be another 2 degrees, assuming that today's Monday. Now, this is easy to make, and this is also pretty accurate in that trends are actually very useful in meteorology. If we can identify a weather pattern, we can assume that that weather pattern is going to last for at least a little bit. However, trends don't last. Think about, look at this trend and make a forecast for a week out from now, or 2 weeks out from now. If it's 68 today, or 68 on Saturday, 70 on Sunday, 72 today, 74 tomorrow, 76 Wednesday, 78 Thursday, 80 Friday, 82 Saturday, 84 Sunday. If you make that trend out over a few weeks, you then get unbelievably high temperatures. If you did the same thing for a decrease in temperatures, you'd get unbelievably low temperatures. A trend would basically cause these numbers to go off to infinitely high or infinitely low numbers. So trend forecasts are also really only good for the short term. So before we continue on, a persistence forecast, whatever the current conditions are, they're going to persist. If it's 87 today, it's 87 tomorrow. That's what a persistence forecast is. Now, as far as a trend forecast is concerned, one of the usefulness of trend forecast, and you'll see this in this week's module activity, is the movement of fronts. So let's say you are a city right here. This is approximately where, well, actually, let's do this up here. This is a more well-known city. This is Washington, D.C. All right, let's say you're at Washington, D.C. And let's say today there's a frontal system that's 1,600 miles to your west. And that frontal system moved 800 miles over the previous day. And let's say that it moves another 800 miles from today to tomorrow. Well, assuming that that trend continues, we can assume that, okay, well, it's going to move another 800 miles over the next day. So if it moved 800 miles from yesterday to today, it's going to move another 800 miles from today to tomorrow. The exercise that I always like to do is assume you have a location with current weather conditions. And let's say all of the weather's moving east at 100 miles a day. Whatever the weather is at that location today is what the weather will be 100 miles away tomorrow. So all the weather just moves one location. It moves 100 miles from today to tomorrow. So like this front, if it moved 800 miles from yesterday to today, it's going to move another 800 miles from today to tomorrow. And then we can use that to give us a better indication of how weather may change. If we know that a front is approaching us, we're probably not going to be able to use a persistence forecast. Why? Because fronts involve major changes in temperature, major changes in dew point, major changes in all weather conditions. So we really can't assume that persistence is going to be a good weather forecast in this case. The other two human forecasting methods that I mentioned are called analog and climatological. Analog is based on history, and it's basically the idea that history repeats itself. If we had a setup, let's say there was a low pressure system off the California coastline, and the last time we had a similar setup, everybody got an inch of rain. Well, since that's what happened last time, we're going to assume that that's what's going to happen this time. And we all make analog forecasts in our life. For example, I know that if I get up at 6 a.m. this morning, I'm going to be on time to work. Why do I know that? Because I got up at 6 a.m. yesterday and I was on time to work. So if it worked out in the past, it's going to work out in the future. So in this case, whatever the weather conditions were based on a previous event are what they're going to be based on in a future weather event. Another good example of this is with El Nino. Previous El Ninos here in California have resulted in a lot of rainfall. The next time an El Nino occurs, or the next time that an El Nino is forming, we can use that to simply say, well, El Nino caused a lot of rain last time, so El Nino is going to cause a lot of rain this time. Now, the problem with analog forecasts is if you have two weather events that look extremely similar, that doesn't mean they're identical. As a result, each one behaves slightly differently. So for example, the example I gave of, well, I woke up at 6 yesterday and was on time to work, so if I wake up at 6 today, I'll be on time to work. The problem is that your morning routine may have to be different today. Traffic on the way to your job may be different today. The conditions that led to you being on time to work yesterday were still going to be different than the conditions today. So the same thing in the atmosphere. The conditions that led to one event are always going to be different than the conditions that lead to another event. And as a result, analog forecasts are useful, but because there's no two weather events that are identical, analog forecasts can only really give us a small idea. The final forecasting technique that's commonly used is what's called a climatological forecast. A climatological forecast uses average conditions to predict the weather for today. So, if you've ever watched a weather forecast before, on a weather forecast, they will give you something such as what the normal temperature for today is. So today the normal temperature would be 85 degrees. Well, using that normal temperature, if you're making a climatological forecast, you would take that normal temperature and that's just what today's temperature is going to be. So whatever the climatological temperature is, that's what the forecast temperature is going to be. Now, the problem with the climatological forecast is that averages are just that, averages. Averages are just that, averages. So let's say you take 10 potato chips out of a bag and you weigh each potato chip, and then you calculate the average of them. There's a good chance that you're going to have potato chips that are tinier than the average, and you're going to have potato chips that are much larger than the average. Well, the same thing is true with weather. Those averages just cancel out the extremes. They cancel out the extremes. As a result, you can't really use an average to accurately predict what the day's weather is going to be. However, in a pinch, a climatological forecast can provide some use. For example, let's say we were to run a weather model today, and the weather model forecasted a temperature of 25 degrees for Cupertino, California. And let's say the average temperature for today is 65 degrees. Can we trust the results of that model? Probably not, because climatologically that seems like a very, very unlikely thing to happen. And that at least allows us to call it into question. So that's really how climatological forecasting is useful. You look at the climatology of the region, and based on that climatology, you make a prediction. Now, the last kind of forecast I'm going to talk about, as far as like what you would hear on the news, are what are called probability forecasts. And you see this in your everyday life. If you open up the weather app on your phone, it'll give you a % chance of rain. It'll give you an idea of what may or may not happen. And these are what are called probabilities. So if the forecast calls for a 10% chance of rain, that's a probability. But what do these probabilities actually mean? Well, there are some terms that you've probably heard on weather forecasts, whether from reading the newspaper, looking on your weather app, or watching a weather forecast, or wherever you get your weather from. And you've probably heard these terms: slight chance, likely, no chance, and so on. Well, these terms are actually used intentionally, and they have some meaning to them. The National Weather Service, which is really the head honcho of meteorology here in the United States, they actually split these probabilities into 5 different categories. The first one is called a no chance. In this case, there is a near 0% chance of a weather event, of a precipitation event happening. In this case, precipitation's not even mentioned in the forecast. In fact, you won't even hear it. They won't say sunny and 0% chance of rain. They're just going to say sunny. In this case, don't even talk about precipitation. On the other hand, if there's a 10 to 20% chance, then what's issued is what's called a slight chance of precipitation. In this case, precipitation isn't really likely, but it can't be ruled out. It can't be ruled out. Usually these kind of chances are very low and they usually don't pan out too much, but every so often they do. Then a 30 to 50% chance is what we call a chance of precipitation. In this case, there's a possibility, there's a formidable possibility that we're going to get some kind of precipitation. At this point, I would start considering it in my day-to-day plans. Then there's what's called likely. In the case of likely, you have a 60 to 70% chance. At this point, it's looking pretty good that, yeah, it's probably going to rain. In this case, you'll hear the term likely in the forecast. So today it's 75, cloudy with rain likely. However, there's still a chance that it won't happen. It just means that it's likely. It means that it's more possible than not. Now, when it's nearly certain, they issue what's called a categorical probability. And a categorical probability is 80% or higher. At this point, you can bet your bottom dollar that, yeah, we're probably going to get some precipitation. And in this case, they won't even say a chance or they won't say likely. They'll just say cloudy with rain. Today, rain. Tomorrow, rain. So if you ever hear it's going to rain, usually they're issuing what's called a categorical forecast. So in the case of no chance, precipitation's not even mentioned. In a slight chance, they'll say, okay, well, there was a slight chance today. In a chance, they'll say, okay, well, there's a chance today. Likely, they'll say, okay, this something is likely. And in a categorical probability, they'll just simply say the precipitation. They'll say cloudy with rain. They won't say cloudy with a chance of rain or cloudy with rain likely. Nope, they'll just say cloudy with rain. Now this brings me to one more thing. Another common thing that we hear in forecasts are what are called rain versus showers. Believe it or not, the two are very different. Rain represents widespread rain. This is rain that occurs over a very large area. It's steady, it's widespread, it goes over a full area. On the other hand, showers are very scattered. They're very off and on. They're very hit or miss. And what off and on means is that it could be raining right now and it could stop raining 5 minutes from now. And then it could rain again 20 minutes from now, and then it could stop raining 30 minutes from now. It also means that some locations are going to get some rain, other locations might not get any. Whereas in the case of rain in the forecast, this represents widespread rain. In this case, most locations, if not all the locations in the forecast area, are going to get rain. Whereas in the case of showers, some places might not get any rain, some places may get a deluge of rain. It just depends. Now, other ways that meteorologists can make forecasts simply involve looking at the sky. The sky can actually give us some pretty telltale signs about changing weather forecasts. For example, if you see a halo around the sun, that indicates the presence of cirrostratus clouds. These cirrostratus clouds usually indicate an approaching warm front, which then means an approaching mid-latitude cyclone. So we can look at the sky to get a pretty good indication of how precipitation might evolve over the next few days. Another much older prediction technique is called red sky at night, sailor's delight, red sky at morning, sailor's warning. This is actually mentioned in ancient texts, including the New Testament. And so what that means is that this phrase has actually been used for millennia. This phrase has been used for millennia. And so this is actually a timeless forecasting technique. Here's what this indicates. Here in the mid-latitudes, weather typically follows the mid-latitude westerlies. What that means is that it travels from west to east. Well, we also know that the sun rises in the east and sets in the west. Well, if at night the sky is red, what that means is that sunlight is reflecting off of clouds to the east, giving you that brilliant reddish tint. That usually indicates that the sun is setting in clear skies and it's reflecting off of cloudy skies to the east. This usually indicates the presence of clouds and storms to the east, and since weather moves from west to east, we can usually tell that at this point, all of the bad weather's past us. Hence the term red sky at night, sailor's delight. All that this means is that all of the clouds and all the storms are to the east. And since weather moves from west to east, we don't have to deal with them. On the other hand, red sky at morning, sailor's warning, this simply means that as the sun is rising in the east, the skies to the east are clear, but the skies to the west are cloudy. This indicates approaching storm systems, approaching weather systems, such as mid-latitude cyclones and fronts. And so this is a key term that's also been used. And like I said, this has been an age-old forecasting technique. Now, why do any forecasts go bad? Well, any of the methods that I mentioned are usually very accurate when used in the short term. If I use a persistence method, if I use a persistence forecast for 5 minutes from now, chances are most of what I say is going to be accurate. However, they're never perfect. And what happens is the difference between my forecast and what actually happens is what's called error. And a slight error in a forecast can greatly create larger errors further out. And so short-term errors become amplified the further out you go into the forecasting period. Why? Because if I make a forecast and there's an error in it, that error is then plugged into an imperfect model, and it creates more error, which is then plugged into an imperfect model, creating more error, which is then put into an imperfect model, creating more error. And so even a slight error can become something that is much larger over a relatively short period of time. So that really wraps up this module. That's everything that we're going to be talking about with weather forecasting. So make sure that you do this activity, this quiz, and this discussion as replacements for any missing modules that you have or any low modules that you have. And that's it for this. Thank you for watching. I'm Terrence Mullins.